Hello and welcome everyone to the first of this series of 4 informative sessions about advanced therapies organised by MWA-TTC. That's the hardest thing I ever have to say. So I'm Christine Bell. I'm going to be hosting today's event and just making sure things are happening and bringing things around. This is very much a session that you requested as patients, and we're going to be recording the session so that you've got a reference to go back to. And over the course of the 4 series, we really hope that we capture some of the latest happenings, the latest science, so that you feel updated and you know what's happening. Today you're going to be able to interact with our speakers. We have joining us today, we've got Kerry Roberts and Philip Newsome, and we'll be introducing both of them. They're just in the screen now, so they're just going to give you a quick wave and say hi to you, so that you can get involved and talk to them. And I'm now going to just show you 3 different ways that you can get involved in the webinar today, so that you won't be able to have a speaking role, but there are some great ways that you can actually get involved with this. So the first thing you'll notice is that you'll see on your screen, you should see a chat bubble. And if you click on that chat bubble, you can go in there and you can already see some people have responded to my question about where are you actually calling from and what is the weather like today. And so far, we've got Laura and Claire and Nisha all joining from a very sunny and vibrant Birmingham, which is good to hear, that vibrant Birmingham. And that's great. So Mohsin, welcome. Hello. And let us know where you're calling from as well, so we just get an idea of location. It's always nice to know when we're doing it virtually, where are people calling from. I had someone the other day who was calling from the Canary Islands, which we were very jealous about. So that's the first way you can get involved, is please add to the chat. So as much as you can, just put in the chat if there's any comments you want to make, if you really agree with something a speaker's said or a question that someone's raised. Use the chat for that, and I'll be watching that as we go along. Oh, and Anne can't hear anything at the moment. So any help for Anne? I'm just going to check with our tech team if there's anything that we can do to help Anne so that she can hear something. But meanwhile, it's sunny in Exeter. It's, oh, another one from Birmingham. Got people from the Forest of Dean. Any technical help for Anne here, who can't hear anything? Yes. Louise is going right. Okay, excellent. Thank you. It's coming up and it's got press the unmute button for the video player. So I don't know if you can read that, Anne, but hopefully that will help you. Okay. Oh, it looks like it's basically sunny everywhere in the country, which is, oh, apart from South Wales where Debbie is, and it's very overcast. I'm sorry about that, Debbie. That's very disappointing. I would move to vibrant Birmingham. It really seems like it's got the edge. Okay, so that's the first way you can connect with us, is using the chat. The second way is asking a question. So if you see underneath your chat, you've got a button that says ask. It's a blue button. If you click on that and you go to ask, you will see, oh, and Teresa's already asked a question, so thank you very much for kicking us off. You will see 3 slightly ridiculous questions that I've asked, and these are for our speakers, and I promise you that they will answer the most popular of these 3 questions. So we're going to ask them about their dream job. Obviously, they're in their dream job, but if they weren't, where would they be? We could ask them about where they'd like to go on holiday, and we've limited it to the UK due to COVID regulations. And then we've also asked them about their favourite ice cream, which they've probably eaten a lot of during lockdown. You can ask the question with your name, as I have and as Teresa has there. You can also ask your questions anonymously. So you can just see there's a little slider button at the top there. Just slide that across as Jonathan's demonstrating, and you can ask the question anonymously. If you now go into, you're looking at recent questions, if you now click on popular and you go over there, you'll be able to see that Teresa's question and my question about holiday locations are trending at the moment. And so upvoting questions is what we call that. And that's a very good way of me. I will tend to ask the questions that are at the top of the list. So we've got a great anonymous question coming in already. So as those questions come in, I'll field them to our speakers. So that should hopefully give you a starting point. We've also got some polls. At various points, we'll just ask you to participate in a poll. And Louise is just showing that poll now. And we're asking you to imagine, you know, like if we were in Vibrant Birmingham, we would have one of those vibrant buffets with really disgusting coffee in jugs and a range of snacks. So we would just like you to choose a snack from our virtual buffet. So just vote for your preferred choice of virtual snack. And you should see the options. If you click on vote, the options will come up and then you can decide, do you want chocolate coated biscuits? Are you going to go for the healthy option, the fruit skewers, bit of lemon drizzle, yogurt and fruit? And it looks like chocolate coated biscuits is winning at the moment. So I'm not sure how we feel about that as health educators. So those are our three ways. So we'll have a look at that and we will be able to show, so you can ask questions, use the chat, and then every so often we'll pop a poll up as well. So hopefully that should get you started. So over to the actual session itself. Now you know how to interact with it all. Oh, if you want to close out of that, just use the little X in the corner, just close out of that, and then you'll get back to the chat. And you'll see we're still trending on. Oh, it's sunny in Leicestershire as well. Perfect. Okay, so we are, and I think it looks like Anne's still struggling on the on her audio. So I don't know if anyone from the tech team can just help Anne out with that. So we're going to go on to the session today. The session today is going to be, we have two parts to it. We've got two speakers. Phil's going to start us off shortly. You can ask questions. After Phil's session, we'll have a short question and answer. Then we'll give you a little bit of a screen break so you can have a stretch, a bit of a, do some Zumba in the background and start thinking about questions you might want to ask in the next round. And then I'm going to hand over to Kerry. And Kerry Roberts is going to be talking about, she's going to give an introduction to cell therapies. So that's the process. So Phil, I'm going to hand over to you because you are formally kicking off our webinar series and also just talking a little bit more about the work that's happening in this field.
Great. Well, thank you very much, Christine. So we're going to put the slide. Fantastic. So so it gives me great pleasure really to take part in this webinar today. So I'm Phil Newsom. I'm a clinician based in Birmingham, and I am the director of the Midlands and Wales Advanced Therapy Treatment Centre. And as you'll see, my proper role here is to be the warm-up act for Kerry, who's going to tell you all about cell and gene therapies. So next slide, please. So what are the ATTCs? So the Advanced Therapy Treatment Centres were funded in an open competition about 3 or 4 years ago by one of the UK public sector funders, so Innovate UK. And they funded us for, in the end, 4 years in the first instance. We're getting about 12 million. So it's a fairly substantial investment in advanced therapies. Now, the reason for these centres was to try and make advanced therapies mainstream, because the feeling was that cell and gene therapies were very exciting. The UK is actually world leading in these, but it's really difficult, even once you've done a trial and shown that something works, it's quite difficult to then roll it out because there are so many specific requirements for these therapies in terms of the shipping, in terms of the monitoring, that it becomes really quite cumbersome. So the aim of our centres is to try and remove those barriers so that it becomes mainstream, so that patients can access them, and also so that companies can, really roll out their products, so we can, drive economic growth as well as obviously improve the health of patients. Now, one of the key things that's really unique and been really amazing about this, the ATTCs, is that there are a real link between NHS organisations, universities, and lots of different companies, whether it's manufacturing companies or whether it's the companies that transport the products in the kind of magic boxes around the country, making sure that, unlike a tablet, these are living therapies, so that when they get transported around the country, we need to know that they're kept in the perfect condition. And you can see here, just in the red box, just how many people are involved in these. So there are 3 of these ATTCs around the country. They're coordinated by the Cell and Gene Therapy Catapult, who are based in London. And recently we've been working closely with a sort of equivalent, London Advanced Therapies. Next slide, please. Just move the, thank you. So in terms of the areas of work, they're kind of captured here on the left. I think one of the really important bits has been the second one here. I mean, obviously the public engagement, which I'll come on to in a second, but has been about hospital or NHS or institutional readiness. So what that is doing is really giving hospitals the toolkit, the skills, the confidence that if they wanted to start delivering advanced therapies, they'd know how to do that. So they'd make sure that they had all the relevant training in place for staff. They had the relevant links to companies that could transport them. I think one of the interesting things, for example, has been how we can use the increasing knowledge around data to help deliver these. That's 2 things. So one is, if you think about when you order a cell therapy product, there's so many steps in that link. You've got to contact the manufacturer. You've got to organize the shipping of the product from the hospital to the manufacturer and back. You then got to sometimes link that in to the treatments that the patients are getting. So for cancer treatments, you need to coordinate the chemotherapy before they then receive the cell therapy. So one of the things that we've been working on is an order.com system which kind of coordinates all of that. So think about it as sort of a super high-tech PA that kind of organizes all of those activities. The other thing that's quite interesting is that when we think about how the hospitals and how the health service pays for cell therapies, there's been a move to try and link the payment to the outcome. In other words, if a cell therapy works, the NHS pays for it. If it doesn't work, they get paid less. So one of those things is trying to collect real world data as we go, so that as you as patients receive a treatment, the system can establish whether or not it's worked or not. So it sort of inputs that into how much we then pay the company for that. So I think that's going to be the way of the future. Next slide, please. So this is the purpose of the webinar today, and we've put a huge amount of investment and effort in that. The whole team have really been involved in that. So one of the things that we did was we tried to understand, what are the perspectives of the public and patient around cell and gene therapies? Do they think they're going to be the kind of magic bullet, or do they think that they're overhyped? Do they understand the risks? So this was a really useful piece of work. And obviously things like today are very many examples of how we try and, communicate the knowledge so that people can make those informed decisions. And I think when we've spoken to industry, I think they really value those insights, because it helps them and us design new therapies and design new trials to make sure that they, they take account people's views. So one of the things on the left, for example, is making sure that as we design our trials, whether they are academic trials or whether they're industry trials, that patients have an input into those to say, no, that's too much, I wouldn't be prepared to do that. And we know that if we do that, we design better trials that give us more meaningful results, and trials, more importantly, that we can recruit to. There's no point designing a trial that nobody's prepared to sign up to because it's just too cumbersome. So I think this is a really important part of what we do. Next slide, please. And again. So for example, here, one of the things that we've been doing with our Centre for Patient-Reported Outcomes, which is led by Mel Calvert, and Lee Egbusi is the deputy director of that, is creating a patient toolkit. And you'll see that's going to happen in the next year or so, which provides all the kind of information you need on advanced therapies. And that will hopefully support you, your family. And I think there's a real recognition here that many of the conditions that will be treated by advanced therapies have a major impact on the family. And that's because those conditions generally are probably more severe, more long lasting. And therefore, it's not just understanding the effect on patients, it's also understanding the effect on their family. So, hopefully through the input that we're going to get by interviewing public and patients in a number of focus groups, we can make sure this toolkit captures everything that is needed. And you'll see Lee's email is on the slide deck here, so you can feed back if you want to participate in that. So that's all I wanted to say. So very happy to take questions from you. But Kerry's going to give you the rundown really on cell and gene therapy. So I'll hand back over to you now, Christine.
Thank you very much, Phil. So I'm just having a look at the questions here. So thank you very much, everyone who's been fielding questions. I'm just wondering, Phil, Teresa was asking a question about whether there's any progress in gene therapies for autoimmune disorders. Is that something that you could give a response to?
Sure. So our focus has been more on cell therapies, but we're looking to sort of work with gene therapies as well. And the sense I get with the gene therapies is they've got more of a focus on, at the moment, the ones that are closest to patients in terms of approved or nearly approved therapies is around some of the rarer metabolic defects, so often conditions that affect children. So I'm sure we will get therapies that look at autoimmune conditions, but they're probably not here just yet.
Great, thank you very much. We've got another question here, which I think might actually go to Kerry, which is about the role of IVIGs in managing side effects from advanced therapies. Is that something, Phil, that's in your area, or is that should we hand that over to Kerry after Kerry's talk?
Well, why don't we hear Kerry's talk, and then we can perhaps revisit the question then to see
let's do that. So again, if there's any further questions that you want to ask, just remember, keep putting them on the poll. Phil's going to be with us for the whole of the session, so he'll be with us at the end, and at that point we'll pull together questions for both Phil and Kerry, so you can they'll bounce between them about who's going to answer them. Yeah, I'm getting the thumbs up from Kerry there. So at this point, I'm going to hand over direct to Kerry, and Kerry is going to just start us off with some slides. As you can see, we are doing a Chris Whitty style of next slide, please. It's not because our presenters aren't competent enough. It's because we're managing the slides at this end so that it appears in the video with them in the picture. So that's the reason why we've got someone anonymously just forwarding their slides for them, and it's sometimes not quite as smooth as we'd like it to be. So hi, Kerry, over to you now.
Great. Can you hear me all right?
We can hear you perfectly. Thank you.
Fantastic. Great. Thanks ever so much for having me today. I'll crack on with the next slide, please. Okay, so today I'm going to introduce you to advanced therapies as a new type of medicine. And I will talk just a little bit about gene therapy versus cell therapy, and then highlight a few examples of these types of treatments, give a bit of context, and help to explain how they can work in the body. Okay, great. When we look at different types of medicine that are in use today, the majority of these are what's known as small molecule drugs. So these are relatively simple chemical compounds, and they can be manufactured by chemical synthesis. So examples you will have heard of are things like aspirin, ibuprofen, and penicillin. And then some medicines are what's called biologic medicines. So these are relatively complex molecules, and they're made from proteins and other substances that are produced through biological processes. And examples include hormones such as insulin, and some types of cancer drugs, and antibody drugs for certain types of arthritis. Now, in recent years, a new type of biologic medicine has been developed, collectively known as advanced therapy. You can just advance the slide, please. So this encompasses gene therapies, cell therapies, and tissue engineering. So these are innovative new treatments, and they offer a lot of potential for treating disease and injury, but they can also be quite complex, and they present some new challenges in how they're produced and delivered to patients. One really notable difference with advanced therapies is they're often made in really quite a different way to more traditional types of pharmaceuticals. So for a lot of advanced therapies, the first step in their production is to collect cells or tissues that might be collected from the patient themselves, or sometimes they may come from somebody else, a donor, or even from multiple donors. And the types of cells or tissues that are collected and how that collection is done will vary depending on the specific medicine that's being produced. Now, some therapies start off with a process called apheresis, which is what we can see here on the left in this first clip. So this process is used to collect certain types of blood cell, and it looks a bit like a regular blood donation. Now, just like for any other type of medicine, cell and gene therapies need to be produced in a suitably licensed facility that operates to what's known as good manufacturing practice. Manufacturing teams have got to follow very well-defined and carefully validated processes, and those processes can be quite complex and take quite a lot of time. And a lot of care is taken to protect the product, so depending on the processing involved, lab operators may need to be gowned up from head to toe, like you can see here in this middle clip. Now, traditional medicines can usually be stored at room temperature or in a fridge, and they often have quite a long shelf life of months or even years before they reach their expiry date. But with advanced therapies, the shelf life can be really quite short. Sometimes it's only a few days, or it might even be a few hours, and it may be necessary to freeze the medicine to really very low temperatures in order to preserve its function. So these delicate products can be thought of almost as a living medicine, and the way in which they're handled and transported needs to be really carefully controlled to ensure that that medicine will still work properly when it reaches the patient. So before I go any further, I'd just like to pause for a moment and have a quick recap of what I mean by cells and genes to check that we're all on the same page about that. So cells are the basic unit of life. Inside our body, we've got an estimated 30 or so trillion human cells, and almost all of our cells contain DNA. So DNA is basically our unique genetic code. You can think of it a bit like a recipe book, and it holds the instructions for how to make everything in our bodies. Now, DNA contains smaller units called genes, and using that same analogy, these are like the individual recipes in the recipe book of our DNA. Now, genes provide instructions that tell our cells how to make proteins. So those proteins are cookies and cakes from the recipe book. And we need proteins, they're necessary for the body to function. Now, if a typo occurs in one of these recipes, i.e. there's a mutation or a defect in a gene, then that might mean that the cell can't produce a protein correctly. Maybe it doesn't make enough of the protein, or maybe it doesn't make it at all. And if that protein is particularly important for health, then that might lead to disease. So that now takes us on to what is gene therapy. Well, gene therapy is a biological medicine that essentially works by inserting recombinant, and by that I mean engineered, genetic material into the body. This is usually done to produce a therapeutic protein that will help to treat disease. And this approach can be used in different types of diseases, including genetic disorders or certain types of cancer. So I mentioned on the last slide that a typo, so a mutation in a gene, might mean that cells can't produce an important protein. So one way we can use gene therapy is to add a normal copy of that faulty gene to the cell, and then that normal copy can provide the correct instructions that tells the cell how to make the protein that it was missing before, and hopefully that will then restore function in the body. Note that here we haven't actually removed that faulty gene, we've just added the normal gene in as well. Next slide, please. Can we just have the next slide? Oh, sorry, no, back one, my mistake. So another potential approach for gene therapy is to actually edit out the defective gene and replace it with a normal copy. So here the end result is much like before. The normal gene has replaced the defective gene, and it provides instructions to tell the cell to start making that key protein and restore function. Now the next slide, please. Thank you. It's also possible to engineer a brand new gene that's not normally found in the body, and that new gene can instruct the cell to start making something that's been designed to bring about a brand new function in the cell to have a therapeutic effect. So here our little cartoon cell is being instructed to start displaying a new engineered receptor on its surface, and we'll see an example of this in real life later on. Okay, so that's very briefly gene therapy. What about cell therapy? So there are some very established treatments already out there that do use cells, but are not considered to be an advanced therapy. So for example, in standard organ transplantation or in blood stem cell transplantation, those cells or tissues are not considered to have been what's called substantially manipulated outside the body. And they're being used to carry out the same function in the patient as they carried out in the donor. To be classed as an advanced therapy, the cells or tissues need to have been substantially manipulated. By that I mean significantly processed or engineered in some way outside of the body. Or they need to be being used for a different function in the patient compared to their original function in the donor. And just to confuse things, if you're not already confused, some cell therapies are also gene therapies. So if you just advance the slide, please. These are sometimes called gene-modified cell therapies. So we'll look at an example of that in a little while. So to give a bit of context, let's look at some example therapies now. If we look at a little bit in a little bit more detail at gene therapy. So there are two main types of gene therapy. The first type is what's known as in vivo gene therapy. So in vivo means within the body. So this involves the direct delivery of engineered genetic material straight into the patient's body. And this can be done in different ways. It might be injected systemically into the bloodstream. It might be injected into a particular site or tissue, such as muscle or skin, or by another route, such as inhalation. Genetic material usually needs to be done in order to protect it and to ensure that it's delivered into the patient's cells successfully. And there are a number of different types of delivery vehicles or vectors that can be used. Something that's naturally very good getting genetic material into cells is a virus. So we can use a virus that's been carefully engineered, so it's no longer capable of viral disease. You can use a virus as a delivery vehicle to carry the engineered genetic material as its cargo and get it safely into cells. You might know that some of the new COVID-19 vaccines, for example, the Oxford AstraZeneca vaccine, uses a product to do just this. Another way to deliver that genetic material can be to pack it into tiny droplets of fat, and that can act as the delivery vector. And this is how the Pfizer COVID vaccine works. So that's the first type of gene therapy. The second type is known as ex vivo gene therapy, meaning outside of the body. So this is the type of gene therapy that's also sometimes called gene-modified cell therapy. So this time, the genetic material is delivered into cells that have been taken out of the body. So this is all happening in the lab. So the cells or tissues of interest are collected, and this might mean taking some blood or perhaps taking a small piece of tumour. It depends on the medicine that's being produced. The genetic material is then delivered into the cells while they're outside of the body. And again, this usually needs a vector of some sort to be used, and often that's a modified virus. Once that genetic material has been delivered, those modified cells are then grown in the laboratory to allow them to increase in number before they are then administered to the patient. So to give a bit of context now, I'd like to talk you through an example of each of these types of gene therapy. So first of all, let's start off with in vivo gene therapy. Inherited retinal dystrophies are a group of rare genetic eye diseases, and they're caused by an inherited mutation in one of a number of genes that are needed for normal vision. So patients with these conditions experience progressive loss of vision, and ultimately it can lead to near total blindness. Now, in September 2019, a new gene therapy product called Luxturna was approved by the National Institute for Health and Care Excellence, NICE. And there are about 100 people in the UK who are eligible to receive this new treatment. And the chap pictured here was the first person in the UK to receive this gene therapy on the NHS in January last year. And his treatment has stabilised his declining sight in his right eye, and it appears to have reversed some of the recent decline he's had in his vision. So how is this treatment administered? Well, it's a one-time treatment. Basically, a retinal surgeon injects the gene therapy directly behind the patient's retina under general anaesthetic. So there's a viral vector that's used to carry a normal copy of the gene that's mutated in this condition and deliver it into the cells in the retina. And once that's been done, those cells can then start producing the protein that they were missing, and the patient's vision is restored. So back to our two types of gene therapy. That's an example of in vivo gene therapy. And now let's have a look at how an ex vivo gene therapy works. So again, this is the gene-modified cell therapy. So CAR T cell therapy is a really cutting-edge type of cancer treatment that's used to train the body's own immune system to kill cancer cells. In some patients that have received this therapy, their cancer has been effectively treated after all other approaches had failed. So these drugs were first approved in the UK in September 2018, and it was actually one of the fastest funding approvals in the 70-year history of the NHS. The little boy pictured here was the first NHS patient to receive this personalised treatment in January 2019. Now, currently, CAR T cell therapy is only a treatment option for people that have got certain types of blood cancer that haven't responded to standard treatments. It's probably only a few hundred people a year across the country at the moment, but there is the potential for it to be used much more widely in the near future, including hopefully for people with some different types of cancer. Right, how does it work? Well, first we start off by collecting some of the patient's own T cells. So T cells are an important part of our immune system. They're a type of white blood cell. They help to protect the body from infection, and they destroy abnormal cells. So the T cells can be collected by a process called apheresis. Basically, some blood is collected from the patient's arm, similarly to a regular blood donation. A machine separates out the T cells and collects them into a little bag, and then returns the rest of the blood back to the patient. The T cells are then sent away to a special laboratory facility where they're genetically engineered. So a viral vector is used to insert a gene into the T cells that will tell them to express an artificial receptor called a chimeric antigen receptor, or CAR for short. So what this does is it reprograms those cells and tells them to recognize a specific marker that's found on the surface of cancer cells. So once those T cells have been engineered into CAR T cells, millions more of the CAR T cells are grown in the laboratory. So it's really important to note that this laboratory facility where all this is happening, it can be quite a long way away from the hospital. Often it's overseas. So it's vital to ensure that the cells are transported safely from the hospital to the lab and then back again once they've been engineered. And as I mentioned before, living cells have got very specific handling requirements. So to preserve the cells, they usually need to be carefully frozen and then shipped at really very low temperatures. And then while all of this is happening, back at the hospital, the patient may be given chemotherapy to prepare them for their CAR T cell infusion. Once the reprogrammed CAR T cells are then given back to the patient, they're put back into the patient's bloodstream, they can find and destroy the cancer cells thanks to that new engineered receptor they have on their surface. Now, one really exciting thing about this treatment is that research has shown that CAR T cells can remain in the body and continue to be active for a long period of time. So unlike many other blood cancer drugs, CAR T cell therapy is designed to be a one-off treatment, and it's hoped it will offer long-term protection against the cancer. If you're interested to learn more about what it's like to receive CAR T cell therapy as a patient, I'd recommend taking a look at a short film that NHS Blood and Transplant have produced, and you can find that by visiting the resource area for this event. I'm sure Christine will talk you through how to access that. And Nietzsche, who's pictured here, very kindly spoke to me about her experience of having CAR T cell therapy in Bristol in early 2019. So those are two different gene therapy examples. I'd now like to talk to you about an example of a cell therapy approach that's being looked at in a large number of clinical trials. There's a cell type called a mesenchymal stromal cell, or MSC for short, that's sometimes also called a mesenchymal stem cell. And this type of cell is being explored for experimental cell therapy approaches to treat a really wide range of different conditions, including neurological disorders, liver disease, heart disease, diabetes, skin problems, and bone and cartilage disorders. So these cells have got the really impressive capacity that they can self-renew, i.e. they can make copies of themselves, but they can also transform into a variety of specialised cell types that have different functions. MSCs have been shown to be able to move towards damaged tissues and they can produce various substances that have beneficial effects, such as limiting harmful overactivation of the immune system, dampening down inflammation, and promoting regenerative wound healing. Now, I'm talking in quite general terms here rather than about any specific trial or product in particular. So MSCs can be found in a few different parts of the body. For example, they can be collected from umbilical cords that have been donated after childbirth. Fat tissue can be removed during liposuction procedures and used as a source of MSCs. And MSCs can also be collected from bone marrow. The tissue is sent away to a specialist laboratory where the MSCs are then isolated from the rest of the tissue. And then those cells are grown in the lab to make enough doses to treat lots of patients. So at this point, when there's lots of cells, these will usually be frozen to preserve them for when a patient is ready to have their treatment. So currently that's only happening as part of trial. The way in which the MSCs are given back to the patient can vary depending on the experimental approach. Just click to advance, please. So some trials might use systemic infusion into the bloodstream. Can we just advance the slide, please? Thanks. And others might involve injecting the cells straight into the specific part of the body where it's hoped they'll have an effect. But that's generally the process. So it's tempting to think that the sky is the limit with these types of therapies. They do hold a lot of promise and it's really exciting. A couple more examples in the news headlines. You might have seen just last week that a new life-changing gene therapy is now available through the NHS to patients with an inherited condition called spinal muscular atrophy, or SMA. So this medicine costs about £1.8 million, making it the world's most expensive drug. But it's administered as a single dose, and it prevents further deterioration in muscle movement and nerve function in babies with this condition. And trials have shown lasting benefits for at least 5 years, and the results may even prove to be permanent, which is incredible news for these patients and their families. The second news article story tells the story of a little boy who was treated with an experimental ex vivo gene therapy in 2015. So this was to treat a genetic skin condition called junctional epidermolysis bullosa. And this is a really devastating condition caused by a genetic fault that causes the skin to be paper thin and prone to terrible, painful blisters all over the body. So in this case, researchers were able to genetically modify some of this child's skin cells and then use them to grow sheets of healthy skin, totaling 9 square feet, that were then grafted onto 80% of the surface of his body. And this child responded really well. It's an amazing story. So is the sky the limit? Well, the reality, of course, is that these approaches are still really new. And in many cases, a lot more work is needed before we start to see these treatments becoming a reality for more patients. And there are, quite rightly, a lot of safety checks involved in getting these treatments through trials into the clinic, and this takes time. But there is a huge amount of investment and activity in this space, so expect to see some more exciting headlines like these. I think that's me out of time. I hope that's given you a brief introduction to cell and gene therapies with a few examples just to give a flavour of how these new types of treatment are being used to help patients. So that's it for me today. Thank you.
Thank you so much, Kerry. That was really informative. There was stuff I learned there. I knew nothing of some of this stuff, so I think it is really exciting. And I could tell from when you were talking about it, it must be exciting for you as a practitioner as well. We're going to, before we go into some questions now with Phil and Kerry, we're just going to give you a short 5-minute break because I know some of you will need to just have a move from the screen and want to put in some dance moves. Some of you will need to get a cup of tea. Some of you will want to write some questions. So again, if I could just ask you, if you're looking at the chat right now, if you click at the bottom where it says ask question, that will take you to where the questions are. And you can see we've got a few questions up there already. And if you like a question, then just give it the thumbs up. If you want to add a question, you can add it in anonymously or you can add it in with your name. There is no such thing as a stupid question on here, and I'm very, very grateful for questions that are easy for me to pronounce because I'm not a clinical specialist, and I'm trying to avoid the question that's trending at the moment because there's 2 words in there that I don't know how to pronounce. So if you can put some other questions in and upvote those, I'd be very grateful. So we're just going to take a 5-minute pause now, so that you can go and get yourself a drink, but also add some questions, and then we'll go into some question and answers. Hello, well, hello and welcome back. Just checking that I look like I'm muted, but I'm hoping everyone can hear me. Yes.
Yeah.
Okay, welcome back. Thank you so much for all your questions. They're storming in now, which is brilliant. Really good to see. And we also posted up a poll during that session, just to find out about your whether you were here as a patient, a clinician, a researcher, or some other role. And so the results from that are coming in shortly. So we're just waiting for the results of that. Once we have those results, I think we'll go into the questions. Oh, I can show the results now. Brilliant. So, we've got, okay, a lot of others. We've got 50% saying they're clinicians and 50% are others. So that's quite intriguing. So we might need to find out a little bit more about that. So we're going to go on to the questions now. And so I'm delighted that Kerry and Phil have not disappeared during the break and not run away and left me on my own to field these questions. And the first question for you is, what is the role in IVIG? I have no idea what that means, so you might want to explain that for those like me that know nothing. So what's the role of IVIG in managing side effects from advanced therapies? Should it be a prophylactic approach or only? Okay, so I don't know which of you would like to take that on.
I can make a comment. So IVIG is intravenous immunoglobulin. Basically, it's used for various different clinical indications, but patients who've had CAR T-cell therapy may need to receive IVIG as part of their treatment. The CAR T-cell products that are currently approved target a type of cell called a B cell in certain types of cancers where those B cells are have become cancerous, or some of them have. So the CAR T cell has beneficial effects in that it targets the cancerous cells, but it also it targets all B cells basically, so it can remove the patient's healthy B cells as well as their cancerous B cells. And what this can mean is that the antibodies that your B cells usually produce, your protection that these antibodies provide you with can be affected, and patients might need to receive this product, IVIG, to sort of top up their antibody levels. In terms of should it be a prophylactic approach, basically meaning giving it in advance of there being any products to kind of prevent problems, rather than sort of once antibody levels have dipped. I don't have the answer to that. I think that would be best posed to a haematologist. I know there is going to be a cancer session coming up later in the series, so perhaps that's one to revisit then. I think this is something that there's work still being done to look at that. I think more evidence is needed to understand whether a prophylactic approach is appropriate or not, but it's not something I can comment on in detail.
That's great, thank you, Kerry. And just, we are going to keep a track. Honestly, these questions are really helpful because they give us an idea of the kind of things people want information about. So although we may not be able to give a complete answer in every session, we will feed this back to the team, and that can be part of information that's updated on the website and other sources later. So thank you so much for all these questions and for upvoting so brilliantly. So my next question is from Mosim. I hope I've pronounced that right. My apologies if not. Who's asking, is there hope for increased tolerability in the future with these therapies, as currently they're extremely toxic? And I don't know, Kerry or Phil, just let me know which of you would like to respond to that.
I can give it a stab. So I think, yeah, there are currently, it varies from product to product. One thing, it's very difficult to talk about these therapies as a one size fits all because they are very different. So talking in general terms as far as I can, that there can be some side effects with some of these treatments. And there's a lot of work going in to try to firstly learn how to manage those side effects, so that if patients do to experience these effects, they have an effective treatment plan to counter them. There's also a lot of research going into improving the therapies themselves, building in new features will make them likely to cause these side effects. Sorry, I don't know whether my my connection's playing up. It looks like the video might be freezing.
So if I can come in, I think that's right. I think at the moment, well, when they were first introduced into routine clinical use, I think there was a concern that there was, this cytokine storm that can occur after the administration of the CAR T therapy, which, could make some patients quite ill and require, hospitalization in critical care and intensive care. I think our clinical experience is that it's not as frequent as we may have feared. And I think going forward, I think there is an expectation that that will become less and less of an issue through perhaps more precise targeting of the treatments. So at the moment, yes, it's a consideration, but we would hope that it would reduce over time.
Thank you, both of you. The next question is, what role is NIHR playing? And you might just need to explain, for those of us who don't know, what is NIHR. There's an awful lot of initials being used.
I know we need to get some more TLAs in, don't we, Christine? So there are several funders in the UK. So NIHR, or the National Institute for Health Research, are one of the larger funders. And their remit commonly is to fund work that's a little bit more applied. So we're not talking about fundamental discovery or experimentation in animal models. We're talking here about work on patient material, work with patients, or even once a therapy has been approved, looking at how you can implement that therapy. How do you change the system so that it incorporates that? So NIHR support this in several ways. They provide funding for standard research grants if somebody wants to ask a research question. They also provide resource to these things called biomedical research centres. So they give just short of £1 billion every 5-year cycle to fund that early translational work of that early study of therapies in patients. And they also provide support to the clinical research network. So this is where hospitals can access a research resource to, for example, deliver clinical trials. So they might get a nurse to come and help with the handling of research participants, as they come up for clinical trials.
Thank you. I'm pleased to say the questions are flooding in, so we'll go on to the next question, which is from Claire. And I think this is Kerry. This came in during your session, I think, and Claire's asking, is this a replacement for hip? Is this a substitute for hip replacement?
Okay. The short answer is probably no. These therapies it's still very early days. It's the first thing to say. To my knowledge, there are not currently approved products that would be used in that setting. There is a lot of work going on to look at tissue engineered products. I didn't have time today to really expand on tissue engineering, but basically they work to sort of restore, replace, or regenerate parts of the body, and so there's definitely scope for these sorts of therapies to be used in joint injury. And a lot of work going on to look at that, but I don't think it's likely to be something in the near future that would replace or be a substitute for hip replacement surgeries en masse. But don't know whether Phil would have anything to add to that.
Yeah, I think at this stage it's experimental, so people are trialing therapies for this, but at this point in time, I've not seen any strong evidence to suggest that we're at a stage where we can consider not having a hip replacement for those individuals that need it. I suspect what will happen first of all will be it will be a therapy you use alongside a hip replacement, perhaps to kind of increase the life of a hip replacement. But sure, I think in the fullness of time, we might look at if you think about when people had stomach ulcers years ago, the treatment was an operation, whereas now it's a tablet. So I kind of hope that that's where we'll end up in years to come.
Thank you. We've got a question here from Kay, who's up in Edinburgh. So hi, Kay. Hope it's sunny up there. Kay's asking, do you think transport and storage issues will be helped by the work and investment in that area for COVID vaccines?
To a certain extent. I mean, obviously, with some of the first vaccines like Pfizer, there was a lot of challenges around the logistics. Thankfully, with the Pfizer vaccine and some of the other ones, that they have lessened. So I think in part, but I think some of the requirements will remain, more rigorous, if you like, for cell and gene therapies, and hopefully not for vaccines.
Thank you. The next question is from Anne, and Anne, I'm really delighted that you did get your audio sorted earlier. And Anne is asking a question on behalf of my good friend Sarah, actually. Is there any chance of celiac disease being considered for therapy treatment?
Well, I see Anne's got a pair of questions. I don't maybe take the pair if that's okay, Christine.
Yes. Oh, yes. And then are any of these therapies suitable for IBD? Yeah.
So I'm not aware of any treatments being considered for celiac, but that just may be an omission on my behalf. Certainly for IBD, there's been an interesting trial looking at mesenchymal stromal cells, so some of the cells that Kerry referred to, for patients with Crohn's disease, so one certain type of inflammatory bowel disease. And what they showed, this was a European trial, what they showed was that if you injected these stromal cells into what's known as the fistula, so the fistula is essentially where there is an abnormal connection between the bowel and the skin. So because of the inflammation in Crohn's disease, you create a track or a route from the bowel through the tummy to the skin, and that's known as a fistula. And what they found was that if you injected these stromal cells into that, you accelerated the healing. So there's currently a further trial going on in the United States, and I think Takeda, I think that's right, bought that for about a phenomenal amount of money. I think it must have been 500 million. They bought the company that did that initial trial. So potentially quite exciting. And in fact, we'll be running a trial for inflammatory bowel disease called Polarize, which will be hopefully opening up in the next 2 or 3 months, which will be looking to treat patients with Crohn's disease with mesenchymal stromal cells. So keep your ears open.
Fantastic. That is great news. A question here. I think this is a really interesting point, because you talked about, I think, how that mind-blowingly expensive treatment, Kerry, that you mentioned, that was earth-shattering for that family, but also phenomenally expensive. So the question is that we've got great potential for advanced therapies, but what are the cost implications for other more conventional therapies when resources are finite?
I mean, it's one of the big challenges of the field is that at the moment, certainly costs are often quite high. I think it's fair to say that, the first time you do something, it tends to be more expensive. And as more experience is gained and improvements are made, hopefully those costs will start to go down. Phil referred earlier to some of the innovative sort of costing models that are being used, where the NHS is kind of negotiating discounts with companies and paying based on results, depending on how well therapies are working. So it is hoped that these costs will come down as the therapies become more established. But yeah, it is an important point, and I don't really have a simple answer. There's a limited budget available for healthcare, and it it's always a balancing act of where that resource can go. But I would say that a lot of work is going on to try and improve efficiencies and to reduce costs where possible at all stages of the process, including the manufacturing that goes on in the laboratories, the ways in which these products are moved around, storage, looking at advances in using what's known as an allogeneic approach, so using cells or tissues from donors to treat multiple patients rather than necessarily having a bespoke product being made for a single patient every time. So there's a lot of work going on to try and reduce those costs where possible, but it will take some time.
Yeah, if I can maybe add, so as you know, in the UK, we have NICE as a form of arbiter. So they'll essentially look at the cost of a medication weighed against the clinical benefit. And it's often quite an emotive point, especially when it refers to or relates to products to treat cancer. And I think it's fair to say that there's been movement on that over the last few years, such that the essentially added value is added to therapies to treat patients with cancer where it's perceived that it's towards the end of their life to make it more likely. And you remember the politics of the Cancer Drugs Fund, which essentially was a way around NICE. I think in ultimate terms, if you have an advanced therapy which as a one-off is effective, then it's very likely to be cost effective. If you have a therapy which is effective and you need to give it regularly, again, it's probably likely to be cost effective, depending on how expensive it is. I think where it becomes difficult is where you have a treatment which is a little bit effective, marginally effective, but costs a lot of money. And I think here the balancing act is, you have NICE, and then you have, human emotion about accessing a therapy for a difficult to treat condition. But, the other way I would ask people to look at things is that if you take the view that the spending within the NHS is a finite amount, if we agree to spend money on something that's not deemed to be cost effective, then we have to replace something else which is more cost effective. So in essence, it's zero sum. So what that says is we'll use this new treatment, which we accept as not as cost effective, but then we need to stop using something else which is more cost effective. So, there is an element of how to balance things up. So although NICE get a hard time, unless people say we should spend a lot more on healthcare, and ultimately that's a political decision, we have to make difficult decisions.
Thanks very much, Phil and Kerry. At the moment, we've just got one question left before I probe Kerry and Phil about their holiday plans. So this question's from Teresa. So while I'm asking this and while they're telling us about holiday plans, if anyone wants to ask any other questions, please feel free to do so. So Teresa was asking, can MSc be used for MGUS? I'm loving all these acronyms. Myeloma and hemoglobin deficiency. Thanks very much, Teresa, for really kind of showing up my lack of medical knowledge and my inability to pronounce things off the screen. So thank you very much for that excellent question. I'm going to hand over to either of you two who might be able to answer that.
Sure. So MGUS is a monoclonal gammopathy of unknown significance. So it's essentially it relates back to conditions like myeloma, so conditions in which there's abnormalities in the production of immunoglobulins. So it's not an area I'm particularly close to. I think that there's been some uncertainty as to whether or not they're going to have a role. In fact, there's some people not sure as to whether or not they're the target as opposed to the treatment in this condition. So I think it's a controversial area at this point in time, but hopefully, we'll get more information in due course.
Great. Thank you very much. Kerry, I don't know if there's anything that you want to add to that.
No, I was just going to add that it's not a mesenchymal stromal cell therapy, but there is a CAR T cell product that's come through recently for multiple myeloma, not MGUS, but no, I'm not aware of any MSc products in that area.
Okay, thank you. We also have another result come in from a poll. Oh, that's the previous one. I'm just going to close that. We don't have that result, so I can go on to our question, favourite question for Phil and Kerry. And given that we can't go abroad this year, where in the UK would you most like to go on holiday? Where's your dream holiday location? And we'll see if we can pay for it for you, you know.
We'll hold you for that, Christine. And there's 5 of us and a dog, so it's going to cost you. Well, I'll go first thing as I started. I quite fancy going to Jersey, actually, because apparently it's in the UK, but it feels like it's in France.
Yep. I'm trying to go to the Isle of Man, and that's proving quite difficult because they're really strict on not letting us in. So it's very safe when you get there, but they're very strict on not letting us in from the mainland. Kerry, what about you?
Well, torn between 2 really. Cornwall, because it's always fantastic, but it'll be rammed for the next few months. So maybe Scotland. We went up to Scotland just in March 2020 before everything. So it would be nice to go back up there, I think, and enjoy some of the great outdoors.
And I'm sure Kay will tell us that Edinburgh is lovely. So thank you very much for that. I can't see any further questions coming up. We have a couple of polls coming up. We've got a poll just going up now about how did you find out about today? And just to give us an idea about what was the method of communication about knowing what was found out. We've got quite an old school one in there that you saw a leaflet posted up. So maybe that was the most successful method. So if you could let us know about that, that would be great. I'm over to thank Kerry and Phil for a really educational session. You've got there's some really nice feedback on the chat about how useful this has been for the people that are here. And I think, Kerry, your slides got a top thumbs up from a couple of people in the audience for their clarity. So thank you both very much for giving up your time, putting so much effort into this session. We're going to show, so we've got the poll going up now as we just wait for that to come in. So the next sessions that we're going to be doing, we've got some great exciting things coming up. So next week we've got a session with Dr. Andrew Feiler and Sheba Khan, and Sheba, who's going to be talking about rheumatoid arthritis, and Sheba Khan, who's going to be talking about treating liver disease. So those are going to be 2 really interesting talks. Then on Thursday, 24th of June, we're looking at cell therapies in treating cancer, and we've got Professor Fiona Thistlethwaite and Dr. Leila Koja. So those are going to be really, really interesting talks. I've seen their slides already. And then our final session on the 30th of June, we're going to be hearing about the role of the pharmacies, which links a little bit to what we were talking about. Kerry was talking about transportation. So that's going to link with that. And then we're only going to have 1 talk in that session, because after that talk, we're going to go into a live interactive session using Zoom so that you can actually talk to each other and network with each other. So that will be a really fantastic opportunity to chat and talk with each other. So my results are in, and for the poll, and it looks like the patient and public focus group communication has been excellent. So I know Laura Chapman's in the audience today, so she'll be delighted to see that. And also the social media feeds. And the old school leaflet was a 0% result. So that's quite interesting. So thank you very much for that. There's a final poll going up just about how informative today's been to you. So that's just useful to go. And when you leave the webinar today, a feedback questionnaire will come up. And you'll also find that when you leave the webinar, you'll see back on the portal where you registered. That's where the resources are, and the video that Kerry referred to will be up on there. You'll also be able to see a video of this recording. It'll probably be, I think it's tomorrow, that will go up and go live. So if there's anything you want to revisit in today's talk, you maybe missed it or you didn't quite understand, you can play that again. So I think that's everything from my side. Kerry, Phil, anything you want to say to wrap us up?
Well, no, just to thank people for attending, and really keen to get people's involvement and feedback in the work that we and the other ATTCs are doing. So I think the slides can be circulated, Christine.
Yes, Louise is nodding at me in the background. We'll be adding them to the portal. Yeah.
So I think Lee's email is there. So please feel free to contact him, and I think Laura Chapman's on the on this, as is Nisha. So again, we're always very keen to hear people's views on advanced therapies and what we could be doing extra. So very much welcome input.
Great. And the results of the poll about the information today, 87% of you felt that you learnt some new information, and 12% it was new, completely new information. So that's great. And 0% said it just confirms stuff you already knew. So it sounds like there's been some value for everyone who's been here today. So that's great to hear. So thank you very much for your time and for your energy. Go and enjoy the sunshine, or hang on, as Jonathan's added from the Hickson group. The chat will stay live, so you can continue adding to the chat if you want to connect to people on the chat. You can continue to do that for the next 30 minutes. And we really hope to see you in the next webinar. Remember, you do need to register for each separate webinar. So don't assume you'll get into the next one because you've come to this one. So you do need to physically sign up for that, and because each one has its own unique link. So thank you very much for everyone. Thank you, Wendy, for your thank you. That's lovely. And Anne, for your comment about learning so much about CAR-T therapy. That's great. Brilliant. Thank you very much, everyone. We're going to wrap up now. We'll see you again.